Number 14. Our researcher wished to compare the average time spent in extracurricular activities by high school students in a suburban school district with that in a school district by a large city. The researcher obtained a SRS of 60 high school students in a large suburban school district and found that the mean time spent in extracurricular activities per week to be 6 hours with a standard deviation of 3 hours. The researcher has obtained an independent simple random sample of 40 high school students in a large city school district and found that the mean time spent in extracurricular activities per week to be 5 hours with a standard deviation of 2 hours. Suppose that the researcher decides to carry out a significance test, can't read today, of HO's mean of suburban equals mean of the city versus a two-sided alternative. So basically the difference is 0 versus not equal to 0. So first of all, I mean, it's a mean. So means go to T. So we can rule out the Z's, right? Second of all, let's just think about what this formula is on the denominator. The standard error formula for two samples. Again, looking at your formula sheet here, and we did this back in a problem before, but it always has the sample standard deviation squared over the sample size. Sample standard deviation squared over sample size, then under the square root. I believe I still have that copied. So if you think about just looking at that formula and applying that to this problem, again, without even really needing to read the problem, it's all about just how it's plugged in. And so it's going to be this C one right here, right? It's going to be 3 squared over 60, 2 squared over 40, because this just has 3 and 2, and this has the square root on the bottom. So, we can rule the other ones out. Probably could have even done this without reading the entire problem.